Hi, welcome back to the 8th week where you can now see the light at the end of the tunnel since we only have 2 more lectures after this before the final exam. So this week we're going to be looking at chapters 20 and 21, that is a safe food supply and the science of food preservation. And what I've chosen to talk to you about today has to do with the safety of the food supply, and I've entitled this, as you can see, "You Are What You Eat, but How Do You Know What You're Eating?" An interesting question. Okay, so let's look at this. First of all, I want to examine how do we know that the food that we're eating is safe. So the Centers for Disease Control and Prevention, according to them, 48 million people contract some form of food poisoning each year. And if you live to be as old as I am, at some point in your life, you're probably going to wind up getting food poisoning. I've had it a couple of times, and it's not very pleasant. So you can see with that number of people, it means that people are getting food poisoning quite a bit, probably at least something greater than, maybe something on the order of 1 out of every 6 or 7 people is experiencing food poisoning on an annual basis. So that's telling us something about our food supply. The Department of Health and Human Services says that the FDA will not be able to support the majority of its food-related activities in the event of a government shutdown. And we already had a government shutdown, or nearly had one, this year. And they're claiming that if that were to happen, they'd only have about 700 staff members available to do all this work. The USDA's food safety and inspection has right now a total of 9,633 employees, and about 1,200 of those have been furloughed. However, field inspections of poultry, meat, and egg products still continue. So these are some of the things that we have to consider, that we've got people out there that are doing these inspections, but it's always possible that because of a recalcitrant Congress, that some of this safety is going to fall by the wayside. What are the various agencies that are involved in actually taking care of our food to make sure that everything is according to oil? The CDCP, that's the Centers for Disease Control and Prevention. They protect the public health from health threats involving foodborne illnesses. So that's just one of the functions that the CDCP has. And you'll notice as I go through this, that there seems to be a fair amount of overlap in the way some of these different agencies function. And I'm not necessarily sure that every agency is communicating its results with every other agency. It's nice that there is a certain amount of duplication of effort, because that gives us some checks and controls. But also, sometimes too many agencies doing the same thing, it's kind of like having too many cooks in the kitchen, and things could actually get out of hand that way. The FDA, the Food and Drug Administration, is responsible for inspecting poultry, meat, and processed eggs, and the Food Safety Inspection Service is responsible for inspecting and labeling of products, and also when products are found out to be either mislabeled or it's found that there's something wrong with the products. This is the federal agency that's involved in recalling the products. So sometimes tens of thousands or hundreds of thousands of packages are going to have to be pulled off of a grocer's shelves and returned, actually destroyed. The USDA is also responsible for the safety of meat, poultry, and certain egg products. So they don't do processed eggs, but they do other kinds of egg products. But there is certainly some overlap between what the FDA does and what the Department of Agriculture does as well. There are 2 other government agencies, the National Oceanic and Atmospheric Administration, the NOAA, and the National Marine Fish Science Service, the NMFS. And these are responsible for the safety, wholesomeness, and labeling of seafood and seafood products. And the HHS, the Human Health Services, is responsible for it's actually the parent organization of the Food and Drug Administration, and they're involved with response and recovery. So they have to respond rapidly, and if there's something that goes wrong, they're the ones that are involved in the recovery process. These are some of the pesticides, and this is by no means a comprehensive list of what you might find in your food, but these are just some things that are present in the food. Some of them are a little disconcerting, and some of them you may wonder where they're even coming from. Well, 2,5-DCP, that's 2,5-dichlorophenol. This is one of the materials that's used to make certain other pesticides, and it is a herbicide in its own right. And glyphosate, we've seen this before. This is Roundup, and this is used in a lot of different places. We don't really know that there's any problem with glyphosate, but it's really not something you want to be eating, but it does wind up getting into your food. And when we say it's in the food, we have to also talk about how much of it is really in the food. Methyl bromide is a potent alkylating agent. It could be responsible for cancer. It's used as a fumigant, which means that it's kind of unlikely. It's hard for me to imagine that it's fairly volatile. It's hard for me to imagine that there'd be significant amounts of this actually present in foodstuffs, but it has been detected. Captan is a phthalimid derived fungicide, and this is a compound that we haven't really looked at. It's a particular fungicide has been found in foodstuffs as well. Now, chloroaromatics have almost been eliminated as pesticides, but you remember that I've said in previous lectures that these things stay in the environment for very, very long periods of time. So what we may be looking at is still the fact that these things are going to be around for perhaps another 50 years or more before they are entirely broken down, and we're going to still see traces of these things in food. And azine-phosmethyl is a phosphate insecticide, a cholinesterase inhibitor, and again, that's something that's showing up in foodstuffs. And even though DDT has not been used in years, I've told you before that DDT, even more so than the chloroaromatics, is extraordinarily stable. And if you put DDT down, it's probably still going to be there 100 years later. So these things are going to wind up probably being in the food chain for a long period of time. How dangerous are they? Nobody really knows for sure, but there doesn't seem, we certainly can't say that any of these things have caused an increase in cancer, in other kinds of diseases. There's really no evidence for that. These things are all detectable, but you have to understand that the level of detection on many of these compounds is down in the probably in the micromolar or even maybe nanomolar level. That is, we can detect maybe billionths of a mole of some of these things. So the question is, are these traces of materials really that dangerous? Some of them, of course, are in might be in parts per million concentration, but again, we don't really know whether these pose an actual health threat or not. Now, it turns out, though, that the federal government is still looking into a lot of these things, and there is what is called a re-registration process that takes place, and the Federal Insecticide, Fungicide, and Rodenticide Act was amended in 1988, and this one of the amendments requires a review of health and safety of pesticides, all those that were registered before November 1st, 1984. In order for those pesticides to continue to be used, they had to be re-registered. And anything that was made after 11/1/84 still had to go through the normal registration process. So it still had to meet the registration eligibility requirements that are summarized in these documents that are called re-registration eligibility decision documents. So these documents determine whether or not a pesticide can be registered. The Federal Food, Drug, and Cosmetic Act, as amended by the Food Quality Protection Act of 1986, mandates that with reasonable certainty no harm will come to infants, children, or other sensitive individuals who may be exposed to pesticides. So when we're dealing with sensitive individuals, and particularly with infants and children, the level that might be not considered harmful to an adult might in fact be harmful to a small child. Any of these things, really, the level of toxicity is actually based on so much absorption per kilogram of body weight. So obviously, a heavier individual is going to have more kilograms of body weight. They'll be able to tolerate a much higher dose than someone who is small, like a small child. And also children, many of the systems that would actually be responsible for metabolizing certain pesticides may not be well developed in very, very young children, and particularly in infants. 1,150 active ingredients have been evaluated, and 384 re-registration eligibility decision documents were issued on that basis. So these re-registration eligibility documents also, in them there are certain directives for risk reduction. So the kinds of things that can be done to, even if these pesticides are going to be used, there are certain things that are mandated in the use of these things and in actually how they're being employed. So one of the things that these regs will actually suggest in some instances that the producer of these of a particular pesticide might want to decide to voluntarily cancel that particular pesticide. The government can force the issue, but voluntary cancellation actually is a much better solution. If the producer sees that there is something wrong with this particular material, then if they just agree not to produce it anymore, then the government doesn't really have to go after them. There's not going to be fines and other kinds of legal cases that are going to arise because of that. There are also imposed limitations in the use of the pesticide, how much of it can be applied, and how frequently it can be applied. And there's also something known as a restricted use classification. We talked a little bit about the fact that although DDT is not used in this country, there are other countries. Well, it might actually, DDT might be sprayed. It might actually have some restricted uses, but it's very, very carefully controlled. And in places like Africa, where it is being used, it's being used in a responsible way, and that's kind of a restricted use type of classification. The use of personal protective equipment is mandated. So people can't just go out there anymore and spray. They have to actually be wearing protective equipment. It doesn't protect the environment, but it protects the agricultural chemical handler and the worker. There are also what are known as restricted entry intervals that are imposed. And these REIs are actually time requirements, and it varies from one pesticide to another one. After you've sprayed, there is a certain amount of time before anyone can go into that area. So that gives the pesticide, if it's going to drift or whatever, it allows it at least to settle out. And in some cases, the REI might be several hours, or it could be several days, or maybe even weeks before somebody can actually go into that area. The user safety requirements and recommendations are also imposed. They've instituted approved use directions and precautions that are indicated on the label. There's tamper-resistant packaging and engineering controls in actually manufacturing these materials. They've also put into place groundwater safeguards and labeling to reduce drift. In other words, when you spray, you don't want the material to be drifting beyond where the point where you've actually applied the material. There's also other ecological safeguards and special programs that have been instituted to protect infants and young children. Now, what can the consumer do to reduce residues of pesticides? Because pesticides are pretty much out there, they're not going to go away, and they're going to be on fruits and vegetables. So these are some of the recommendations. Eat a variety of fruits and vegetables, because if you're eating only one particular kind of fruit, like if all you do is eat pears, well, pears might be sprayed with a particular kind of pesticide, and you're going to be taking in an awful lot of that pesticide, where there may be other fruits or vegetables that are not going to be sprayed quite as much. So by eating a variety, you're actually reducing the amount of residue that you can take in. Wash all produce, and that also includes organically grown produce. And there's a number of reasons for doing that, because we're not just talking about the pesticides themselves, and even so, the organically grown ones, remember that we did say that because of drift, it's possible that someone who's growing something organically, they may still have pesticide residue on their crops, even though they're not applying them to the crops. And the other reason for washing it is that that organically grown produce is much more likely to have bacterial contamination on it. So you're washing it just to get rid of some of the bacteria and perhaps soil-borne viruses that might be present on that particular fruit or vegetable. Use running water, and don't use dunking and soaking. So you don't want to dunk and soak your fruits and vegetables, because when you do that, they're going to get into the water, and then you're leaving them in the water, and when you pull them out, there's still going to be a residue on there. So the running water actually kind of washes that off to some extent. Dry with a clean cloth or paper towel. That again removes some of the stuff, some of the water that might have pesticide residues on it. Scrub firm fruits like melons and root vegetables. Scrubbing actually, of course, also helps to remove some of this. And whenever you're dealing with leafy vegetables like cabbage and lettuce and things like that, you want to remove the outer layer of these vegetables, because the outer layer is most likely to be where the pesticides are going to concentrate. So you want to remove that and discard it. And then again, if you peel fruits and vegetables whenever possible, that will also remove some of the residue. But on the other hand, a lot of fruits and vegetables, particularly things like potatoes, it's actually the skin that has a lot of the vitamins in it. So you're kind of removing possibly some pesticide residue, but you may be removing some of the beneficial part of that as well. And then whenever you're eating meat and poultry, it's probably a good idea just in general, from a health consideration, to remove as much fat and skin, which also contains a lot of fat in it. But trimming the fat and skin from meat and poultry, the other thing that it does is that when animals are raised, whatever it is that they're eating, which might also be contaminated with pesticides, that material, once it's absorbed by the animal, is most pesticides, virtually almost all pesticides, are lipophilic types of materials. So they're actually going to be absorbed by the fat. So we're going to tend to find things like PCBs and a lot of other kinds of pesticides are going to tend to accumulate in the fat. So by removing that, again, we're making these things a little bit safer. Organic foods. Are they safer or healthier than non-organic foods? Well, let's look at some information that I've presented here. Published data does not support the contention that organic foods are more nutritious than conventional foods. So people have looked at nutrition, and there's a lot of anecdotal evidence out there that says, oh, yeah, these things are much better. People that eat organic foods, they swear by them. They say that they're tastier and that they're healthier, and they make a lot of other claims that really are not necessarily borne out when actual scientific studies have been done. One of the things that seems to be the case is that when people eat organically grown foods, the people that actually are buying these foods tend to eat more of them than people that are eating the non-organic foods. So that means that even though there may be fewer pesticides and fewer other additives that are present in these organic foods compared to conventional foods, the fact that people are eating organic foods or eating more of them, it may, to some extent, it may wipe out whatever benefit that you would be getting from the fact that there were lower amounts in the organic food. Now, on the other side of the coin, the EPA estimates that approximately 1% of all domestic and 3% of imported foods actually exceed the pesticide safety standards that they've set. And these standards are pretty low, but that's still something that one might want to have some concern about. Exposure to pesticide residues and antibiotic-resistant bacteria may be lowered by consuming organic foods. But on the other hand, you may have a lot more bacteria on the organic foods than you would have on the other foods as well. A bacterial problem, however, is eliminated by cooking foods at the proper temperature. So if you heat these things up enough, if you don't eat them in the raw state, then you're really going to eliminate bacteria. Bacteriophages, which of course are viruses, have been used to kill things like listeria in deli meats and hot dogs. And there's a lot of people that say, oh, you're putting a virus on my hot dog? That sounds really awful. And of course, these are uneducated people who don't realize that a bacteriophage is not capable of infecting an animal, and certainly not a human being. So the fact that these things are put on there really does not harm you in any way, but it is a beneficial kind of thing. Now here's something that's not so pleasant. Most cows now are injected with RBST, that's recombinant bovine somatotropin. This is a bovine or a cow growth hormone. So it's in most milk. And there are some problems associated with that. Now, it turns out that one of the things that this can do, because these growth hormones also act a little bit like the human growth hormones. And one of the things that this causes, girls in general over the last several decades have been having their menarche, that is the time when they begin to menstruate, when they start to develop sexually. It's happening at a younger and younger age. And now there have been cases of girls as young as 7 years old who are actually beginning to go through puberty. And some of this is actually attributed to the use of these growth hormones and other hormones that are injected into cattle to actually make the cattle produce more milk, or it may be also producing, they're growing faster, they're producing more meat. So these are things that one probably should be concerned about. I suppose if you're getting your milk from an organic source, then you have some assurance that the bovine somatotropin is not actually in your milk. Now they're also using things like carbon monoxide and nitrogen. And carbon monoxide, although it's poisonous, no residues of this actually remain on the meat. It's treated prior to packaging as an antioxidant, and it tends to preserve the color of meat. So you know that when meat starts to spoil, it gets sometimes it'll get an off color. The problem with this is that because it actually preserves the color, it may mask actual bacterial contamination of the meat, so the meat may actually start to spoil and you won't know about it. And one other thing that's done to foods that some people that are into completely organic types of treatment of food may take issue with is that food is being irradiated. Irradiated food does not become radioactive. It's It's passed through a device that is putting out a lot of gamma radiation. The radiation does not induce radioactivity. The food itself never comes in contact with radioactivity, but this radiation will destroy pathogens that happen to be on the food. It will destroy yeast. It will destroy molds. All these kinds of things that you don't want in your food that are going to cause spoilage can be eliminated by radiation. So I consider that to be a non-issue. Who determines whether something is organic or not? Well, it seems to be the U.S. Department of Agriculture has the final say in this. So they regulate how organic foods are grown, how they're handled, and how they're processed. If a producer sells less than $5,000 a year of organic food, then they don't have to go through the whole certification process, which can be fairly involved, and it's probably fairly costly as well, but they still have to follow the USDA standards for organic food, and there are certain requirements for organic food, and among them are the fact that if you're going to call something 100% organic, it must be completely organic or made from all organic ingredients. So there can't be anything, I guess, that's synthetic in there. It has to be just natural ingredients. There's also something that gets the USDA organic seal, and that can have as little as 5% of other additives to it. But there must be at least 95% organic before you can display the USDA organic seal. Now, products that contain at least 70% of organic ingredients can have on the label the words "made with organic ingredients." But anything less than 70%, you can't even use the word organic at all. And people that violate this, for every incident of violation, they can be fined up to $10,000. PCB contamination of food. Well, we talked about PCBs before, and I perhaps gave you the impression that PCBs are kind of a non-issue, and I really think, as I said before, that perhaps we worry a little bit too much about PCBs, but I just wanted to give you some figures regarding PCBs. So in 1980, a study was done, and fish that were taken from Lake Ontario had PCB levels that range from 0.11 to 4.90 parts per million. That's not a lot of PCBs. PCBs that got into this rice oil. There's a fairly significant amount of PCBs that were introduced into this oil in Kyushu, Japan. And that oil was sold, and it was used in restaurants, and people also used it in their homes. And an estimated 16,000 people were sickened because of this. I think there were also some incidents of chloracne that occurred as well. I think I told you, perhaps last week, that people died from this. But when I actually went back and looked through the literature, I can't find one confirmed case of somebody actually dying from the Kyushu rice oil. There was some mention that there might have been 5 people, there might have been 5 deaths that were questionable. It was a possibility that these people might have died from that, but there was no real certainty. And if we're talking about 5 people dying out of 16,000, can we really be sure that that was caused by the rice oil? Now, the EPA sets a PCB limit in drinking water of 0.5 nanogram per liter. That's 0.5 billionths of a gram for every liter of drinking water. And the Food and Drug Administration sets limits between 0.2 and 3.0 parts per million for a variety of foodstuffs, including dairy, poultry, fish, shellfish, and infant foods. Certainly the infant foods would fall at the lower level. Some of these other things might go up to the higher level of 3 parts per million. These are still fairly low levels. So you can see, at least up here, that 4.9 parts per million would already exceed the 3.0 part per million level. But again, they're PCBs, and I think a little bit too much stress is put on these particular things. Now, there's other things that we have to worry about from in food, and that's bacterial and viral contamination. So these are some of the things that one can get from food. Some of these things will cause extreme intestinal distress, which would include vomiting and nausea and diarrhea and a variety of other kinds of symptoms. Some of these things will actually kill you as well. So salmonella, there have been deaths attributed to salmonella food poisoning, and coliform. E. coli generally tends to not be something that kills, but there are now resistant strains of E. coli that actually I think have caused some deaths. The norovirus, also known as the Norwalk virus, is another virus that's been found on foods, and Clostridium botulinum is the microorganism. Clostridium perfringens is another organism that can cause a kind of food poisoning, but botulinum is an organism that produces the botulin toxin, and the botulin toxin is one of the most potent and deadly toxins on the face of the earth. So this is something that you don't see it very often. It tends to occur in canned foods, and if you ever see a can of food that is bulging, there's a very good chance that the pressure that's built up in there has to do with the fact that there's Clostridium botulinum in there, and you definitely do not want to use that food. That food needs to be destroyed. Listeria is another bacterium that causes problems. Campylobacter is another one. Back in the 1980s, I interviewed for a position with a chemical company in the Milwaukee area, and as I was up there for my interview, I found out actually the day that I returned that the water supply of Milwaukee, and thank God I hadn't had any water, but the water supply of Milwaukee was contaminated with cryptosporidium. Now, cryptosporidium is something that really is of agricultural importance, because this is usually caused by agricultural runoff from animal feces on farms. The contaminated feces get washed into streams, and in this case they got washed into something that ultimately fed probably the Milwaukee River or something. They got washed in, and this fed the water supply of Milwaukee, and by the time it was detected, a number of people got food poisoning from the, well, I guess we would call it water poisoning, but got it from the cryptosporidium. Shigella is another one, another enterobacterium, and Staph aureus is another one. So all these things, and others as well, wind up getting into food. And it's something else that we have to be careful about. Generally speaking, cooking the food very well will destroy most of, if not all of these materials. Danger in seafood. So seafood, again, now a lot of these things that I'm talking about here are things that you have to worry about more if you're eating things like shellfish, which tend to concentrate a lot of these things. And of course, this is one of the ways that Hashem has actually protected us by making these things treif. These are things that we don't consume, but nevertheless, some of these things can wind up in fish that we would consume as well. And these algal toxins that I show up here in the top, domoic acid, saxitoxin. Saxitoxin causes a condition called paralytic shellfish poisoning. and this can be fatal. And brevetoxin causes another condition called neurotoxic shellfish poisoning. So both of these materials, which are present when there are algal blooms, and also things like dinoflagellates, which are microscopic creatures that live in the water. When these things, certain varieties of these start to increase greatly, you'll get things like a red tide, and this winds up killing a lot of fish usually. But if it doesn't kill the fish, these fish may actually bioconcentrate some of these toxins. People eating these fish, they can get very sick or they can die. Another big concern are things like methylmercury, which is actually this cation here, and even worse than methylmercury is another compound called dimethylmercury, and dimethylmercury is really very, very nasty. So dimethylmercury is a material that of all the chemicals that I've worked with in my career, this is one particular material that I would never ever want to handle. There was a not too long ago, I think it was probably back in around 1995, there was a researcher who was looking into some of these alkyl metal compounds. She was a professor at Dartmouth by the name of Karen Wellerhan, and she was someone who was well trained in the use of things like dimethylmercury, which is a very volatile liquid. She was wearing all the protective gear that she could, and this dimethylmercury that I'm showing right here is a compound that is used in nuclear magnetic resonance studies. She was actually studying alkyl cadmium compounds, but this was used as a standard in her investigation. And she was putting, I guess, a few drops of this into an NMR tube, and some of it, although she was wearing protective gear, she had things like latex gloves, and I think she may have had another glove over that. She spilled a couple drops of dimethylmercury onto her gloved hand. And seeing that, she immediately removed the gloves. She washed her hands very, very thoroughly. It turned out that about, I think, 3 or 4 months later, she was starting to experience some neurological problems. She went to the doctor, and they started to do some tests on her, and they found out that the levels of mercury inside her body were enormously high. And she actually, within, I think, maybe 9 months to maybe 10 or 11 months after this incident occurred, Professor Willerhan died from mercury poisoning. So this is a very, very dangerous material, and these things are in the water. Mercury gets into the water, and then it's metabolized and it's converted into things like methylmercury, which is less toxic, but the dimethylmercury that I've shown here is extraordinarily toxic. Now the next item down here, Fukushima fish, this tends to probably not be so much of a problem, but it certainly was a problem in Japan after the tsunami that occurred, and I think it was in, if I remember correctly, I think it was in 2011, and the Fukushima nuclear plant had a somewhat of a meltdown, and it was a very, very serious release of radioactive material. Much of that got into the water and contaminated the fish. Those fish, as far as I know, all the contaminated fish were destroyed, but it turns out that there's still isotopes, some radioisotopes from that event that have actually washed up or have been found in sea life all the way over on the other side of the Pacific, that is on the like along the California coast. So I don't think that Fukushima fish are necessarily a problem, but again, it's something that one might have to worry about. And this Anisakis parasite is actually a roundworm, and this is been found in wild Atlantic salmon, and it does cause, this is something that can cause problems for people that eat this fish. Although it's the parasite is specific to the salmon, it will also infect a human host as well. And then tapeworms and flukes have also been found in freshwater fish and in Pacific salmon. And I've seen estimates that say that maybe more than 50% of the Pacific salmon may have some of these parasites present in them. So if you like to eat sushi, you might want to worry about things like salmon being present in the sushi. Even if there are tapeworms and flukes or whatever, and the fish is usually inspected. If it's very obvious that these things are present, the fish would not be sold. But nevertheless, even if there were traces of these things, eating the fish to the proper temperature would kill them. So there'd be less of a problem associated with that. Okay, so kosher, yes, but is it safe? So the first thing that I want to mention is that kashrut does not guarantee safety at all. We observe kashrut because Hashem told us to observe kashrut, and we like to think that eating kosher is healthier and it's safer, but in fact, that's not always the case. Now, here's an interesting thing that I myself was not aware of until I started to do this investigation, that 88% of all chickens raised in the United States are treated with the antibiotic roxarsone, produced by Pfizer Laboratories. And this particular antibiotic is an arsenic containing antibiotic. It's actually an arsenic acid. And it turns out that organo-arsenic compounds are supposedly not nearly as poisonous or dangerous as things like inorganic arsenic compounds, like arsenic oxide or arsenic chloride or elemental arsenic. But there is evidence, in fact, that these compounds can be bioconverted back to the inorganic form. So it raises the issue of, is this safe? And there have been no, as far as I know, there's been no evidence to indicate that anyone's ever died from eating chickens because of the arsenic concentration. But kosher poultry and organic poultry has a higher level of listeria and salmonella contamination than trafe poultry, just by virtue of the way that these things are grown and processed. So in the case of organic poultry, there's really no bactericides that are being put down. But in the case of kosher poultry, because trafe poultry is actually it's dumped into, I don't know whether it's boiling water or hot water, and you can't do that as part of the koshering process. So what's done is the feathers are left on the reason that they do this with trafe poultry is it makes it easier to remove the feathers. The feathers in kosher poultry, the feathers are actually left on the bird, and then there's some kind of a device, a machine that removes the feathers, and these birds have to stay in that machine for a much longer period of time than a trafe bird would, and that increases the possibility that bacteria are going to be spread by that process. And the last item that I have on here is it really kosher, and how can we tell? Well, I mean, there's a number of ways to tell without, of course, you're looking for the hechsher, but there are other ways of telling whether something is kosher or not, or at least ways of telling that it's not kosher. Because kosher meat, or at least poultry anyway, has a much different look than trafe poultry. It tends to be yellower. It tends to look a little bit healthier than the other poultry. But the one really significant difference between the kosher and the trafe poultry is the salt concentration. And there were a couple scandals that occurred. One of them back in 1987, and I remember this because we were living in Chicago. My family had just moved to Chicago, I think in '85, we'd only been here a couple of years when this hit. The Shalat kosher chickens, they were producing something. They were producing a lot of prepared chickens, chicken Kiev, and this material, although it was certified as kosher, in fact, at least it seemed to have a hechsher on it. It was I guess it was a fake hechsher, and the people that were selling this stuff, these Shalat, and the individual that was the president or owned this company, was fined $250,000. Of course, they lost their kashrut, and they were essentially put out of business. There was another incident that occurred in Monsey, New York, more recently. Had to do with something called Shabbat Butchers, and this was a butcher that was renting space in another kosher facility, and my understanding is that someone who had, I guess, was looking at their meat and saw that whoever they were buying their meat from happened to be, I think, his brother-in-law's company, and he said something to his brother-in-law that he was looking at this meat and he saw this hechsher on it, and his brother-in-law said, "Well, that's very unusual because we stopped selling products to Shalat Kosher some time ago." So his brother-in-law, the original fellow, said to himself, "Well, maybe this stuff has been sitting on the shelves for a while." So he goes back down and he looks at this stuff and he sees that this material is still out on the shelf with this particular hechsher on it, and he says he asked the fellow, the butcher, he asked him where he's getting his meat from, and he says, "Well, we're not from some other supplier." And he checks with that supplier and he finds out that they're also not supplying the meat as well. So it turns out that this was in fact a scam, and that these people were taking treif chickens and they were just putting a phony hechsher on them and selling them. So this is something that we shouldn't have to worry about that. There's a mashgiach who should be taking care of this, and I guess there probably was one, but somehow this person was able to put one over on the mashgiach, and they were selling this fake treif meat. My final slide, entitled "Made in China," has to do with the fact that China is one of the largest food exporters, and we actually buy a lot of food from China, which kind of surprises me. For instance, apple juice. I was surprised to find out that 50% of the apple juice sold in this country actually comes from Chinese sources. And these things are very high in pesticide residues, as are things like Chinese tilapia and cod. These have high concentrations of antibiotics and growth hormones. The Chinese don't have they don't really protect their citizens the way that our federal government protects us. They don't protect their own citizens, and they can care less about whoever citizens of other countries. If they don't care about their own citizens, they really don't care about anybody anywhere else as well. So these high levels actually are exported to the United States. Processed mushrooms. I'm told you should never buy processed mushrooms, canned mushrooms, because a lot of this stuff comes from China, and the levels of pesticides on the processed mushrooms are very, very high. And also, if you're into organic foods, and as I said, I certainly don't recommend organic foods, although they certainly don't hurt you, there's a lot of illegal labeling. So if you see something that's labeled as organic, like garlic, and it's coming from China, it probably is not organic. And the worst thing that's happened is this compound that I'm showing here. This is a symmetrical triazine. We've seen this compounds like this before. Atrazine is a herbicide that is a symmetrical triazine, a 1,3,5 triazine. So this is 2,4,6 triamino 1,3,5 triazine, and this particular compound is called melamine. And melamine is very, very high in nitrogen. And if you're selling things like baby food, for instance, you want to build up, you want there to be a certain amount of protein present in there, because young children, they need the protein for growth. So there's a requirement that there has to be a certain amount of nitrogen present in baby foods. So what the Chinese were doing, rather than putting in actual vitamins and amino acids, they were putting melamine in there, because melamine is 60% nitrogen by weight, and this is a toxic material. So you don't put a lot of it in there, but it boosts the nitrogen level. And children, there were I know of at least 5 deaths that occurred from melamine poisoning. These were put into things like baby formula. So these, again, are very, very dangerous kinds of things, and we have to be very, very careful when the USDA does probably inspect some of this food, but you can't, obviously they can't inspect every single thing that comes into the country. We don't have enough manpower to be able to do that. So if you're going to buy anything from China, the Chinese make some nice scientific products, but I certainly would stay away from their food, because their food to me looks like it's very dangerous. I think that's all I have for you. Yes, it is. So again, our usual exam, 25 questions. I'll see you all next week.